Right, let's take a look at this problem. Combination sum 2. Given a collection of candidate numbers, candidates, and target number, find all unique combinations in candidates where candidate numbers sum to target. But in this case, we can only use one candidate once. And we have multiple we can have multiple candidates. Duplicate values as candidates. So again, I want to like as it was in the combination sum 1. I want to recurse and search for the solution space, and for that I want to hold my result. I want to create the result, and I want to combination helper. I want to have this function, and I want to at the end return the result, but also want to pass this in result so that I can change it. But I also want to pass the candidates here. I want to pass the current candidates, which I will be using in the while recursing and using it to return. And also I want the sum of candidates to be targets. So I also want the current sum, which will be 0 at start, and then I also want to pass the target here. All right, so I want to define this combination helper here. It's within this function. So candidates will be candidates, and I want to have current. Maybe like remaining candidates, and the current will be current, and then the sum current sum, and I also want the target and result like that. So what's my base case? I want to stop when remaining is empty, and if my current sum is greater than or equal to my target, right? And if my current sum is equal to my target, I want to append to results. But can I have duplicate? So I cannot have like 161, 116. We only include one of them. So okay, for that, let's see. And here I want to have like current sorted current will be equal to sorted current. So I want to sort it, and then here maybe I don't even need this. Yeah. So here I want to return, but here if the target is equal to that, so I want to calculate the sorted, and if sorted current is in the results, I don't want to include it. So if it is not in results, I want to append it to the results, the str current. And to recurse, what should I do here is to go over the remaining ones. So for every I'm going to use I and candidate as a can. In enumerate, I'll just enumerate over the remaining. And if, let's see, so okay, so I just want to com helper. So I'll just call it again, but when I use one of them, I cannot use it again. So for that, I want to create new. I also want to create the name current, because I want to add my current. Like in this for loop, I take one from the remaining, and I want to recurse with that in the current. So I want to pass it there. So my new current will be equal to my current candidate. I'm just gonna name it like this so it's more descriptive. and here new remaining will be equal to remaining, and I don't want to include, so I want to go until I and plus. By the way, I need to do it like this because I want to append it, like add it to the current, and here I want to okay, let's see. So I don't want to include I, and here remaining I want to start from I plus 1 until the end. So I have like that. I also maybe for efficiency I might have something like sorted current will be equal to new, but I'm not going there. But again, if I have something like if I have 16116, I don't want to search the path 161, right? For that, I want to sort this, and then if sorted current is not in result, then I want to go that path, and I want to pass the new. Just 1 second. All right, I'm back. So here we are passing new remaining, and also want to pass what is the second argument? New current. I want to pass current sum will be new current sum plus current candidates, and target will be same, result will be same. So I'm adding this just to make it more efficient, because I think in the cases where we have like 161 here, 161, later on I might have somehow like at this point I have 611, and I don't want to have that, right? But I'm starting from left side. Maybe I don't need it, but let's run and see if it works. Okay, I made a typo there. 1 second. Okay, so I'm not returning here anything, and what might be the reason there? Let's print the current. Let's see if I'm adding on to what? Wait, it's 8. If it is 8, I don't want to go there. It is not there for every 10. Wait, what is this? If the current sum, which will be at the start at 0, come here. What is the current sum here? It's 10. Don't I just return that? What is going on? Is it always 10? All possible ways. Yeah, I should stop when it is greater than that. I don't understand why it is traversing there. If it is, yeah, I should just, instead of there, I should like and this should be, and this should be less than great should be less than or equal to target sum. I mean target. If it is less than or equal, I want to go there. But I forget to print current and current. Let's see if I'm going if it is going correctly. So in these cases we're not appending, and what might be the reason there? Wait, what's my output? I have plenty, so it's not in that. Maybe I can also optimize it like this. And str current, new current. It's not in that. Not remaining, or now it should work. Let's see. And also, where is the other print? Oh, it's not there. Okay. So yeah, we are searching through all the solution space, which is 2 to the power of, like, you include one or you don't include it, and 2 to the power of candidates. So here is that. So let me edit here. So time is of 2 to the power of candidates, and space is the cannot use others, which would make it candidates, or to the power of candidates, because we can only use one once, so that makes it space O to C, where let's say that the target is 8 and you have like 1, 2, 3, 4, something like that. If you use every one of those, then the height of the tree is the number of candidates, so it will be O of C. So I'm just gonna submit it and see if I'm stuck with some edge cases. If there is a problem with some edge cases. Actually, I should check it before submitting it, but let's see. See if we got a luck. All right, so here 27. What's this sum here? How many? 1, 2, 3. Maybe I should just, when sum is yeah. So here, if some candidates if some candidates is greater than or equal to targets. I don't want to do that. Let's see. Oops. Let's see if this works now. Run. Let's make it 27. Okay. So if it is possible, we want to go there. So those cases where it's not possible, then we're just wasting too much time. Also, wait. I can have that. What is this? Hmm. 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 Can I solve this problem with hash table, maybe? Can I do that? Yeah, that. Something smaller. You need 7. All possible. 1, 6. Go through items, every possible one. Here I'm checking. Okay, what if I do this? If that's the case, maybe I can, oops. Okay, let's try this. Okay, it works. Because I was sorting the possible spaces, which was taking too much time. So let's try this. And I think it's also possible to do it with hash tables. But if this doesn't work, I will try that. Again, do I have a problem? Wow. Wow. Hmm. Hmm. If you have this, can we solve with DP? It says backtracking. Maybe I don't have. Okay, I have to check the if statements here. Not remaining. Okay, let's. I have that current remaining. Item. Oh. So maybe, yeah, I guess I also want to check one thing. Let's say that I have a one, like one, one, two, two, a items. That will be a list of those all items. Values, dict values, all of them, like that. Then what would be the case if you have something like that? One, two, three, four. This of us. Okay, that works actually. That actually works. So current string, that's tuple that, and have it here. Sorted. It's not string. It's source current. I'll just put it there, and then here, that's values. And whenever we have, maybe it's because n to the power c times c to the power c. Maybe that's because that might be the reason. So let's see. So the current will be tuple like that. It's not in that. We just go in, and then here there is also tuple sorted like that. Result there. Let's see if it works. What was the thing that I had a problem with? Console. Let's see if this works. But I think I still have a problem here. How many ones do I have there? Time meets exceed. In this case, I should have like 3, 5, 6, 7, 8, 9, 10. There are too many of them, right? Too many ones. Okay, let's say that we have this, and then okay, I'm not sure how to handle this. It's not in. Maybe it's because every time we sort, we're wasting too much time. So we just go in, go in, go in, go in. Remaining is changing. Now at the end of this, I have 30. which is just 1 like that. And then in the next iteration, just at this end of this, I will have 1 at this position, and I just check that it is like that. And I immediately want to check also, like, if tuple current, if tuple if current is not in results, and then I want to sort it. Maybe let's see if this works. Like, I'm not sure, but invalid type of integer. New current, not a valid type of integer. I made a mistake there. What was my? Maybe it passes, but I'm not sure. Some it exceeds. Okay, let's see. It's probably checking if I don't know. Let's look at Python solution. So here it is checking. You're just increasing I plus 1. Oops, I made a mistake. No, it's correct. Let's see. Yeah, I increase that. I give the path is that, and if I is equal to idx, to continue, we just sort the candidates. Yeah, maybe it's just before starting, if we sort it. Yeah, that makes sense. Then I don't even have to sort it in these cases. And this is the same thing. Okay, let's see what was my problem. So if current is greater than target, in that case we just return that. Okay, no problem. If it is equal to that, we append the path, which is the current actually, to results, which is also correct. But instead of this, because this is not working like that, I want to turn it back to the original version, because here, where is that? path. Okay, so since this is a combination, you cannot use the same thing. Then in that case, instead of passing this remaining, we can just pass the candidates. Candidates. So that was a mistake I made. So I also pass length of candidates, and here I want to pass IDX, and here I also want to pass not remaining but candidates. I don't know how to do this. Here I just go not like this, but for I in range from IDX to the length of candidates. Let's see. I pass IDX, new current. This will be I. I want to start with that. I cannot use the same thing, so it should be +1 here. And also here, I don't even have to check. I just can. I don't have to do these. If it is equal to target, I can just result that append the current. And okay, my current path is that. If it is less than, do I need this? If it is more than I want to continue, right? If the last edit index, if the last edit, the previously added one is similar to the current one, then we already I guess I could do it that way. But it is only the cases where if the I is greater than that. That's also a weird one. So if okay, let's see. So if if I is greater than IDX and if the candidate I is equal to last I minus 1, then we just want to continue, and then instead of this you can just put it here, and then I don't have to sort it here, right? The sorting it, what might be the reason for that? Oh, because then you have the multiple ones side by side, and if you have duplicates, then you're just skipping them using this continue. So that's actually a valuable thing to do. So okay, I also want to increase I by 1 because my pointer IDX, I want to increase it, and here my current can, this will be candidates. So from here, like candidates I candidates I, like that. Yep, that's correct. But then I don't need to pass res there. Oh, because it is in that function. I have access to that, so I don't have to pass that. I don't have to pass that. I just have to pass. I also don't have to pass that. But my current IDX, it should be 0. My current sum will be that. My target and result, I can go there. And I don't need this. Do I need this? Check. I mean, it's just one check, so it's often, so it's okay if I do it. But here, let's see. IDX, current sum. This is the path, actually, current. And yeah, target and results. I don't need those. And we have list. I just have results there because I changed it from dictionary to list. So it works now because. So this is the thing that I'm confused about sometimes. So in combinations, you cannot use the thing that you used. So you just have to behave it like it's not like a permutation in the combinations. So you just want to increase the IDX, and you just have to pass the index like there. But okay, let's try if this is working. It will work because of this condition, because I'll just continue. I think it will work. Yeah. So it looks like we just by sorting we get rid of most of the redundant work. So yeah, I think I also could do it in my code where I should have done like a previous. I could have a previous just before this, but that would be still too complicated. This is much cleaner because you sort it and then you have access to the previous element you added because you are just increasing the index there. So I'm just gonna submit this. So let's think about the complexity here. So it's 2 to the power of. In each one of them, you just call it 2 to the power of n, I think. So which is c, and then your this is also c. What are the complexities? Complexities. Let's see. What's the complexity? To the power of n combinations. Number of combinations. N times n to the power of n. I don't think so because we're just having this. But we go over every possible candidate, which is n. So we might need that. And the space is also number of candidates because we have results, and also we go down candidates many times in the recursion. So yeah. Right.